Morning. How are you? And today we would like to discuss about an important topic on statistical significant test. So, as a machine learning, if you've been in machine learning world, definitely the statistical knowledge is very important and an essential for everyone to understand it. Actually, when we deal with multiple variety of data, we need to know what kind of statistical significant test to do perform on it. Here we listed about six the essential the statistical significant test which we need to know about it. So first we need to know what is a hypothesis. Hypothesis is nothing but an idea which comes from your thought, which you like to give a kind of an abstract definition or whatever it may. And the hypothesis, we can say that in statistics world, null hypothesis and alternative hypothesis. With anything in that you prop in your mind, right? And what would you say is the particular the product is expensive, right? You don't know about any more information why the product is more expensive, right? You don't have any evidence. But literally, unknowingly, you are saying that the prices of the particular product is expensive, right? In theoretical world, in statistical world, whatever the idea which you express or which you are aim at to find a relevant you want to prove, your assumption will be taken as a null hypothesis. So we take it as it is, taking as considered as a null hypothesis. After collecting the enough informations, the data, relevant data, proper examine, then we say that now the price of the product is not expensive. With that, the results, and we reject that with the evidence of data that we examine with the alternative hypothesis. So the relevant data is evident for us. The price of the product is not expensive, then we need to accept the alternative hypothesis. So these two things is very needed actually. Let's say the first test, let me go with the Fisher Extat test. So two groups of people, one group which given a drug, the other group of set of people, uh, they were not given a drug actually. And over a period, the both group of the people with drug and without drug consumption was analyzed, and at the end of the month, with the statistical data, we found that the number of death which is higher either by consumption of a drug or not. Based on that, you can see the graph, right? This evident that the number of patient from a group of people who have taken the drug, the number of death is lesser than those the other group which they don't given a drug, they don't consume a drug, the number of death is higher. So it revealed that the statistical significance with the consumption of drug is good. It's comparatively better than the group of others without drug. So when you have deal with the two kinds of a group with the x and y axis with and without drug, number of deaths are between these two groups. So here you can see there are two variables which involved in x and y axis that clearly tell that you need to go with the Fisher Extat test. And what if you have two group of people with the drug and without drug, and if you want to analyze the tumor size, right? So the same people with the drug and without drug were analyzed over a period, and they analyzed that the tumor size, whether it is increased or decreased. By this student t-test, it clearly tells that the patients, the group of set of people who consume drug, the tumor size is much reduced than the other group whose or consumed did not consume the drug. So when you go with the x-axis two category, two variables, and y one continuous variable on the tumor size, because why this tumor size we are giving a continuous size, right? We cannot predict or we cannot say that we cannot quantify that it will be 2 or 5, right? It's keep on growing, right? So it is, that's why it is a continuous data. The size will be growing over a period, day by day. So it's a continuous access. So in that case, you testing would be student test would be your model. And the next thing is think about the same thing. Here we have y-axis only one continuous variable, right? And think about there is one more model we have ANOVA. How the student t-test and ANOVA is different is that if you have more than two groups, then your ANOVA will be your recommended model. Here we are taking without drug has no drug, and with the drug A, drug B means we are dealing with three set of groups with the tumor size where your y-axis continuous. And here we are examining the three persons, three set of groups clearly say that drug A, the tumor size is much lesser than drug B than no drug consumption. So in that case, you got a statistical test on the ANOVA, right? And there is one more other thing is, what if you have x-axis is greater than 2 and y-axis greater than 2, means you have two variable. You have two variable greater than two variable in x-axis and y-axis, then your choice would be the chi-square test, where here we can see the no drug, drug, and drug B across the percentage of dead actually, right? And you can see the y-axis here we are getting the dead are alive actually. When you compare with this Fisher extra test and Chaiswar test, you can see that it is the category, right? Here drug and non-drug, and here drug A, drug B, non-drug. And in terms of Fisher test, you have dead or alive. The same thing also here we have dead or alive. So it clearly tells that you two more than two variables which is involved on both x and y axis, then your choice would be your chi-square would be your choice. And the other thing is regression analysis. It always tell you that you are in a continuous way between a single variable or multiple variable. You can see there is a set of people on the continuous they are consuming day by day your drug, and based on the consumption of a drug the tumor size which got reduced actually. You can see this the line which has come from left to right in a higher to lower. It's a negative it's a kind of a negative line actually. So if we negative lines means based on the consumption of a dose, the tumor sizes the tumor sizes gradually get reduced on a over a period. And if you involved with multiple drugs, actually drug doses which is greater than two, then you need to go with a multiple regression actually. So it always identified there is, and based on your drug consumptions, your tumor size is reduced. That's why it always do a estimation of the relationship between dependent variable or more than or one, how it is actually impacting the cause and effect like that. So once we know this, all the statistical significant tests, then it is easy for us to implement, to ideate what is the appropriate machine learning algorithm we can go ahead with that. This is very important for any machine learning or a data science person to understand the statistical significant model. I hope this is fine and kind of a little understanding on the statistical model. I tried to explain you for an easy understanding. Thank you.